Okay, I'm going to go to the next page of the notes. Here we go. Hadoop. Example 1, how to solve this. Okay, I have taught y'all this before, but it's not intuitive, so I won't be offended if you lose this out. So when there's no number there, this implies square root. We're dealing with square root. So I'm going to go ahead and solve this thing very quickly. Here is how this basically works, the best way you can do it. I'll do it one at a time. Since this is an even number, I know that this negative is going to turn into I, period. I know I'm going to have an I in there. So that's one of the things. If I did this 36, if I take the square root of 36, I know that it's going to be 6. If I took the square root of x to the 6th power, and how does that look like? Well, let's see. If I had x third times x to the third, that would give me x squared. So if I took the square root of x to the 6th, I would end up with x to the third. You see the relationship between that? 6 divided by 2 gave you 3. The power divided by this gave you 3. So I'm going to do this. I pulled this all out, and now I have to put those all together. So have I evaluated everything? The answer is yes. So I go 6i x to the third. Now that's the answer. That's the way I worked it. But now I'm going to show you how I want you to do your work. Do y'all remember this long, annoying process? Well, this is why I taught you that long, annoying process, because it gives you better understanding. So I'm going to break it apart like this. When I have my multiplication things, I put these all into separate radical houses. Notice it's a square root, so I don't have any numbers here. But we'll have to worry about that on the next examples. So what's my square root of -1? Since it's an even power here, it's an I. What's my square root of 36? It is 6. What is my square root of x to the 6th? It is x to the third. And then that's how I put it all together. So that's how I do these things. I'm going to go ahead and work the next example. Example number 2. This is another square root. Mister, what's that 2 doing there? Y'all, if it was something else, you'd see 2 little numbers. The big number is going to be in front. The little house number right here is going to be here, the nth root. So now I'm going to go ahead and break this apart. I'm going to do this. 2 times the square root of 48 times the square root of x to the 4th. I do not think this process is as miserable as y'all complain about. It's not that hard. Just do it. And now remember what has to happen here. So there's that method of like doing the cake method or prime factorization, but it doesn't teach you the number sense behind it. So we have to look at the basically inside this number for perfect squares. What are our perfect squares? Well, there's 4, there's 9, there's 16, there's 25, there's 36, there is, what's the next one? 749. Do you see that? What's going on here? These are my perfect squares. These are my perfect squares. So can I divide any number into this thing? And I see it. I can divide, what can I divide 48 by? There's 8, there's 16. Yeah, 16 by 3. So you ready? I can break apart 48 into 16 times 3. So here I go. I'm going to break up 48 into 16 times 3. 16 times 3. And I'm going to do it with the same house this time because you can do this. I want you to see it. I'm going to amp up the abilities a little bit. You can put the number in the same house, but make sure you separate it at 16 times 3, which is 48. Now, x to the 4th, how do I find out the square root of that? You just divide this 4. You take 4 divided by the 2 that's hidden there, and you end up with x squared. Next line, I'm going to be like a machine. I have my 2 times my square root of 16 is 4. There is no way to simplify the square root of 3. And then I have my x squared. Now I'm ready to put it all together again. I have my house. So there goes my 3 inside my house. I have my variable. Goes right here. And then this is 2 times 4, which gives me 8. And that's how I simplify these, and it works for every problem. I'm going to do the next examples on another video.